So I will now introduce you LCMS, that is how the liquid chromatography mass spectrometry is attached to LC, that is liquid chromatography is attached to mass spectrometry. Mass spectrometry is I will come to its principle. First, that LCMS is a technique in which the separations achieved from the liquid chromatography are analyzed by mass spectra. That is, analysis is done with the help of mass spectrometry. You have seen now UV visible detector, and instead of the UV visible detector, here the detector used is mass spectrometer. So from the interface, that is where the mobile phase enters into the UV visible detector, that interface is stopped and it is connected to the interface of mass spectrometer. And in most of the cases, the interface used, these are the ionization, depending on the ionization sources. The main advantage of mass spectroscopy or mass spectrometry is that it provides the identification of compounds and helps in the elucidation of the structure of the compounds. So when we combine liquid chromatography and mass spectrometry, we call it LCMS. Now the problem is the solution, the mobile phase which is coming into the mass spectrometer, that is evaporated and the analytes are left behind. So, and with the help of ionization sources, the metabolites are analyzed. So mass spectrometry works by ionizing the molecules and then sorting and identifying the ions according to their mass by charge ratios. So you can see HPLC is connected to the atmospheric pressure ionization, or ESI electrospray ionization, or atmospheric pressure chemical ionization, and or it may be ion guide, quadrupole array or octupole, and then it is fed to the detector of the mass spectrometer. And on you can also connect this directly to the computer. That is, at the same time you can run both UV visible also and mass spectrometric detection also. The main disadvantage of mass spectrometry is that it is an destructive technique. That is, the sample gets destroyed. So there are many problems in connecting the HPLC and MS. First is in liquid chromatography there is a liquid phase operation, and in mass spectrometry there is a vacuum operation, that is for sucking the ions from the source. And HPLC, it can work only up to 25 to 50 degree, and for mass it works 200 to 300 degree centigrade, because here the evaporation of the solvent take place. And in LC we do not have any mass range, and in MS up to 4000 daltons for quadrupole MS we can use. In liquid chromatography, buffers are inorganic buffers, and in mass spectrometry we require pure volatile buffers. And in liquid chromatography 1 ml per minute flow is equivalent to 500 ml per minute of the gas only, whereas MS accepts 10 ml per minute gas flow. So almost 50 times less of the sample which is coming from the LCMS is required for the analysis. So there are conditions that the mobile phase which is coming out of the solute, you know that is very expensive, but it should be low cost, and solvent strength and selectivity, they play a very important role. Another thing is that column for LCMS, it may be difunctional or trifunctional silanes which are bonded together, and most widely used column for LCMS is the fast LC column, and these fast LC and short and small columns of 15 to 15 mm they are used. Some micro columns of the instead of the large column, that is 20 to 150, very small micro liquid chromatographic columns are used. So mass spectrometry, the sample preparation also plays a very important role in the analysis. Now problem, what is the biggest problem in mass spectrometry and liquid chromatography? It is, one thing is clear, that separation, that is LC liquid chromatography is जो samples which are coming out, they are analyzed on the basis of mass by charge ratio. The other biggest problem is that there is decrease in the vacuum level, and it prevents the target ions from reaching the detector. So for this purpose interfaces are to be used. Means we have to design special interfaces for connecting mass spectrometry to the liquid chromatography. So if we consider now what is mass spectrometry, we have a sample inlet. In general, a mass spectrometer consists of sample inlet, ion source, mass analyzer, detector, and recorder. Sample inlet, that is the sample enters into the mass spectrometer. Ion source, where it bombards with the electron and ionization takes place. In the mass analyzer, different masses of the sample are analyzed, and in the detector they are detected, and means they are separated on the basis of their mass by charge ratio, and by the recorder they are by a recorder they are recorded. So like you have a sample, this is the sample, it is evaporated and it is converted into vapors. In the vapor phase, the electrons they bombard with it and they cause ionization of it. And then in the presence of a vacuum, they are allowed to pass through where the sample passes, and like in this way ions are formed, and these ions of different charges then they are allowed to pass through an electric and magnetic field, and the heavy ions they travel slow and the lighter ions they travel faster, and based on that these ions they get separated like A, B and C, or the different fragments which are formed in the sample. They are the different fragments which are formed in the sample, they are ionized. So that is, मैं रिपीट कर दूं एक बार फिर, sample is volatilized and then high energy electrons they bombard the volatile sample. Ionization takes place. Then they are allowed to pass through electric and magnetic field, and depending on their mass by charge ratio, that is heavy ions they travel slow and the lighter ions they travel fast, so they get separated. So depending on this we get signals, and these signals are recorded in the mass spectrometry. Now what is the history of mass spectrometry is that first of all in 1897 mass spectrometry experiment, that is, you must have heard about Sir J.J. Thomson model of the atom. That is, atom was when we pass electrons through a atom or a thin foil of gold, it gets it passes through the thin foil of gold, and there is most of the space around the atom is empty. So by this way, that is, mass spectrometry is based on the experiment, that is X-ray, the cathode ray tube experiment of Sir J.J. Thomson. And in 1953, देखो 1897 से लेके 1953 तक बहुत ज़्यादा डेवलपमेंट नहीं, देयर वाज नो development in mass spectrometry. Wolfgang Paul invention of the quadrupole and quadrupole ion trap, these two things. What is quadrupole? It is based on the 4 magnets, and ion trap system was developed, and this got the Nobel Paul got the Nobel Prize in 1953. In 1968, Malcolm Dole he developed electrospray ionization, and in 1974 atmospheric pressure chemical ionization system was developed by Horning, and this in 1983 Vestal and Blackley work for thermospray, this was also developed. Here are like Sir J.J. Thomson and Dempster, who got the Nobel Prizes in physics, and they developed the cathode ray tube. So mass spectrometry, in mass spectrometry, that is the molecules or the atoms, they are weighed. That is depending upon their mass by charge ratio. So what does a mass spectrometry do? Mass spectrometer gives the molecular weight, and we can calculate the molecular weight from the molecular ion which is formed, and we can get the molecular formula depending upon the various elements present. And now it is possible that all the elements which are present in the periodic table, they can be determined by mass spectrometry. So mass spectrometry is incredibly valuable in getting structure from fragments of biomolecules such as peptides and proteins, and also natural products and also organic structures, and it can give information about chemical structures. So we can analyze, most of the elements present in the periodic table. So basic components, as I told you, first we evaporate the sample, it is converted into vapors, and then it is subjected to the high vacuum system. That is we have the inlet system, and from the inlet the sample passes into the ion source. Then various ions are filtered depending upon their mass by charge ratio and detected and given to the data system. These three things, ion source, mass filter and detector, these are under high vacuum. Whereas in HPLC we do not need any vacuum pump, and depending on the inlet system, that is, it may be connected to HPLC, GC or different ionization sources, and that is, ion can be formed by matrix assisted laser desorption system, fast atom bombardment, electron ionization or chemical ionization. And mass, then they can be separated by time of flight, quadrupole, ion trap, magnetic sector and Fourier transform mass spectrometry. And detection is done by electron multiplier or Faraday cup, and data system, it can be a computer system consisting of a Unix or Mac system. So for the mass system, as I told you, there is an inlet, ion source, mass filter, detector and data system. So these four things, they are necessary for any mass spectrometer. And the inlet, that is, it transfers the sample into the vacuum of the mass spectrometer, and the mass analyzer, you can say, it is the heart of the mass spectrometer, and this section separates the ion either in the space or in time, and according to their masses to charge ratio, ions are separated and they are detected, and the signal is transferred to the data system for analysis. So this it is converted into that is solid, liquid, vapor. It is ionized and then it is analyzed by the mass analyzer, detected by the uh, detector, that is when ions that strikes the detector in to detect the ions, and data system records the uh, various ions. So this is how the mass spectrometer in fact looks like. The main components. First is probe. Here in the beginning you connect the that is uh, in outlet, which is from gas chromatography or mass spectrometry or any other system. That is, from this the sample is introduced, and this electron beam, it produces the electrons and it ionizes the sample. Ionization of the sample takes place. Then only few ions they enter into this tube, and they are allowed to pass through electric and magnetic field, and depending on their movement they pass through detector slits, and through a detector they are recorded. So ions that are heavy, they move slowly, and ions which are lighter, they move fast. So this is the basic instrumentation setup required for mass spectrometry. So in mass spectrometry, that is, molecules are neutral. Molecules are neutral, and when the electron is bombarded with a beam of electron, there is m plus electron, m positive plus 2 electrons, that is m positive, this molecular ion or radical ion is formed, and in the presence of voltage, that is electric and electric field, these ions are accelerated and energy is given to each particle, which is equal to their kinetic energy, that is half mv square. So potential energy is equal to kinetic energy, and you can find that is half mv is equal to zv. That is, ultimately you can say that ions are separated on the basis of their charge by mass ratio. Similarly, when charged particles, they are accelerated by the applied voltage, they enter the magnetic field, then the attractive force is hv, and that is hzv, this is equal to mv square over r, and ultimately we can say that m by z is equal to h square r square over 2v, that is, it is dependent on the magnetic field, that is mass by charge ratio, and its ionization. So in mass spectrum, the main important thing is the most intense peak. The most intense peak is known as the base peak, and it is highest peak, and it is assigned a relative intensity of 100. So the rest of the peaks, they are known as fragment, or they are corresponding to the fragmentation pattern of the molecule. Because the fragmentation pattern is remaining constant at the constant applied voltage, so molecular ion or base peak reformation remains the same. So the molecular ion peak gives the molecular weight of the compound, and the molecular ion peak is the if the molecule has atoms and these atoms have isotopes, then depending on that the molecular weight of the substance or the ion, it may have a slight difference, and the isotopes with different atomic masses, they are separated differently. So fragment ions, they are formed directly from the molecular ion by the cleavage of a bond, and so these are known as fragment ions. And always the fragment ions, they have lower masses, and these are used as the building block to construct the molecular structure. And fragmentation of molecular ion cleavage bond occurs in heterolytic and homolytic cleavages. Another thing is metastable ion. Base peak or the molecular peak molecular ion is stable species, but at the same time several ions with different mass by charge ratio, they are formed and they are called metastable ion. These ions, they undergo further dissociation, like M1 positive, this molecular ion, it undergoes dissociation and it forms M2 2 positive, and neutral fragments may be formed. If M1 is changing to M2 and charge is doubled, what will be the molecular mass? The molecular mass will be halved. Molecular mass will be half हो जाएगा बेटा. In this reaction, that is so M2 positive is said to be the metastable ion, and peak M due to such fragmentation occurs at the lower mass. That is in relation you will have that metastable, the relation between metastable ion and M1 and M2 positive, you can write it as M star is equal to Mz positive over M1, that is depending on their masses. Now like in ethyl bromide, what is the molecular weight? CH3 12 और 3 15 और 14, and bromine total mass is 110 or 108 depending on the masses, depending on the isotopes of bromine. So you have C2H5 15 to 14 29, you have a peak at 29 C2H5 ion, you have 79 corresponding to bromide ion, 81 another isotope of bromine, and in total bromine and CH2 100 or ethyl bromide, you have 108 and 110 depending on the M by Z values. So this is the common in mass spectrometer in most of the laboratories. That is how the system looks like, and now depending on the ion, in what we can do with the ion interface sources. We can have direct chemical ionization. Direct chemical ionization, what it means? We react the ions with other gases so that chemical reaction takes place and ions are formed. Moving wire or belt interface, and this is the same thing, that is some wire or belt that is around that separation of the ion takes place. And thermospray, that is we heat the ions which are formed to a very high temperature. So by this way ionization takes place. For HPLC, the main thing is you take it granted that the whole of the sample and mobile phase and buffer which is coming from the outlet of HPLC is not directly fed or submitted to the probe of mass spectrometer. About, as I told you, about only 1 to 2% of it is utilized for the ionization purposes at a very slow rate. And in chemical ionization, under solvent rates, that is 10 microliter per minute, 10 microliter per minute, they are sufficient. Whereas in HPLC, we have a flow rate of 1 ml or 0.5, 0.1 to like a 4 ml maximum is the flow rate of the mobile phase. So this is atmospheric pressure chemical ionization. That is, in this case, like this is the from this is the sample which is coming from the column. Here we take the nebulizer gas. Nebulizer gas का क्या function होगा? Beta, nebulizer gas will carry the sample forward. Nebulizer gas will carry the sample forward, and then this is heated, that is corona discharge in this electrodes, that is further ionization takes place, and only few ions they are allowed to pass to the detector, that is they are allowed to pass through the analyzer and they are detected. And जैसे इसमें heating, counter electrode, this corona discharge electrode, this is heated to a high temperature, and depending on this the chemical reaction takes place. That is atmospheric pressure chemical ionization. This नेबुलाइजर जो इसमें से होगा ना, जैसे इसके टिप पे आके ड्रॉप बन गई, पहले जैसे सैंपल आ रहा ना, सैंपल इज कमिंग एंड इट इज प्रेजेंट एट द टिप ऑफ द दिस स्प्रे ट्यूब. बेटा ये काम नहीं कर रहा. हाँ, यहाँ पे आके स्प्रे ट्यूब पे ये खड़ा हो गया, इसके आगे ये जा नहीं सकता अपने आप, तो इसको ले जाने के लिए नेबुलाइजर गैस इज यूज्ड. फिर इसका अंडर द हीटिंग एंड दिस undergoes chemical reaction. So bath gas and other things, that is it is transfer ion optics, that is only few ions are allowed to pass through, and under a low pressure, that is pressure pump, that is a vacuum is maintained, and they are analyzer, and from analyzer to the detector. Same thing, that is here you have the moving belt interface, same thing, that is it keeps on moving, and again then electroionization or chemical ionization, and then it is allowed to pass through the this is and again subjected to the mass spectrometer, that is, and from here that is LC, this sample is coming, and this is the belt, that is it keeps on rotating, and it is the heater which heats it, and in this case that is from again this nebulizer gas carries it to the electrodes, and where ionization takes place. Thermospray, as I told you, that is thermospray LCMS system. The eluent from the column is vaporized, and a portion of the vapor is transferred to the mass spectrometer, and the rest of the vapor is pumped as a waste. So finally vaporized sample through an electrolyte is allowed to pass through the ionization chamber. So here the ionization takes place. So we have mainly the ionization sources are electrospray ionization, atmospheric pressure chemical ionization, and atmospheric pressure photo ionization. In electrospray ionization क्या होता है बेटा, strong electrostatic field and heated dry gas is allowed to pass, and heated gas causes solvent to evaporate, and ions they are formed by the electrostatic field. So sample is converted into the gas phase and carried into the analyzer. ये देखो, first is evaporation takes place, analyte ions are ejected with the help of nebulizer gas. There is only the few ions, they are under heated nitrogen drying gas, they are allowed to pass. So in electron ionization, what type of reactions they take place? You have a molecule, and when electrons bombard to it, it is converted to a radical molecular ion, and these two electrons are given out. This molecular radical ion undergoes fragmentation, and this may be a cation or a radical ion, and further cation may form another cation and one neutral molecule. So these are the fragmentation processes, and these fragmentations they combine together and they may form like radical ion and neutral molecules. Next is chemical ionization. In chemical ionization, selectivity is achieved by considering the proton or electron affinity. In chemical ionization is mostly suitable for the halide ions, and it is also suitable for the double bond of the molecule, that is in the molecule where double bonds are present. Chemical ionization. I told you that it is suitable for halide ions, Halide ions, they have lone pair of electrons. Similarly, double bond also has a, means it is having a very high electron density. So depending on that sensitivity, that is the chemical reaction takes place, and double bond, that is it can be detected, that is electron capture detection, that is ECD, selectivity is possible. That is, in this chemical ionization, the sample is mixed with methane, isobutane and ammonia, and it leads to the formation of a pseudo molecular ion, M plus H positive, and these adducts ions are characteristics to identify the molecular weight. And the disadvantage is that it is not as effective as electron ionization, and spectra are not very much informative in case of chemical ionization, because we are using another chemicals, that is gases, ammonia, nitrogen or other gases, and they lead to formation of other products, and the spectrum may not be reproducible, though enough for library search. And commercially available computer spectral libraries are not available, and so more information and more ion source maintenance is required. दूसरा मैंने बताया था कि भाई एटमॉस्फेरिक प्रेशर, केमिकल आयनाइजेशन, सेम प्रिंसिपल है बेटा, एटमॉस्फेरिक प्रेशर पे that is the sample or the this is heated, and with the help of the nebulizer gas, this is known as nebula. This nebulizing gas carries the sample, and in the presence of this is under whole vacuum, and this corona discharge needle, it causes ionization, that is it is electrically charged, and as soon as the this sample analytes, they come in contact with corona discharge needle, ionization takes place, and only few ions they are that is they are capable of passing through this capillary under electric and magnetic field. So by this way this ionization takes place, and photo of the electric discharge needle, you can have a UV lamp which can cause photoionization of the sample. This the ions due to photoionization which are formed, they are subjected for further analysis. Now, on the basis of mass analyzer, we can classify mass spectrometer into 4 types. First is quadrupole, second is ion trap, and third is time of flight mass spectrometry, and fourth is Fourier transform ion cyclotron resonance mass spectrometer. क्वाड्रुपोल, क्वाड्रुपोल में क्या होता है बेटा? आयंस दे आर allowed to pass through a trajectory of 4 quadrupole rods. Ions, that is through a source slit, they are allowed to pass through a, that is radio frequency is applied on these on this these 4 quadruple these rods, and ions with stable trajectory, they are detected. Ions with which have different trajectory, they are not allowed to pass. They are driven back, and then it passes to the detector. So based on only M by Z is then determined, and stable oscillation takes place, and ion travels in quadrupole axis with corkscrew type of trajectory. That is, ions which can pass through the exit slit, then they go to the detector. बस थोड़ा सा बेटा. और टाइम ऑफ फ्लाइट मास स्पेक्ट्रोमीटर, टाइम ऑफ फ्लाइट मास होगा है. टाइम ऑफ फ्लाइट मास स्पेक्ट्रोमीटर में क्या होता है बेटा, velocity of the two ions are created by uniform electromagnetic force applied to all the ions at the same time, and they are allowed to accelerate down a flight tube. ये देखो जैसे हवाई जहाज उड़ता है ना कि भाई, that is from where the sample comes, and in this higher energy zone, that is which is applied by the ring electrodes different, these ions which are formed, they are traveling a very long trajectory, that is they are just flying, and then they are further referred to the detector. So by this way, that is these ions which are passing, they are allowed to travel a very long distance under the electrostatic field. They become highly energy, and some ions they become of lower energy, and then they are detected. So this is time of flight mass spectrometer. आयन ट्रैप मास एनालाइजर, ये भी जैसे आपके अलग अलग आयन बढ़ गए, फ्रेगमेंटेशन हुई. फ्रेगमेंटेशन समझ गए ना आप कि भाई जब एनालाइट के ऊपर इलेक्ट्रॉन्स बम्बार्ड करेंगे, डिफरेंट fragments are formed. Then depending on the selection, you can select depending on the energy applied. Some of the fragments, they can be trapped. That is, ions entering into this chamber, depending on the electromagnetic fields, they are trapped, and there is they oscillate in concentric trajectories, and then again, that is, they are given to the detector. So देखो, this is ion source. In this ion source, there is mass ion analyzer. All the ions, they are not trapped. Only the ions where your resonance with the external magnetic field takes place, these ions are detected. That is resonance AC voltage. You apply voltage in across these two rings, and based on that, few selected ions, they are trapped in these two plates. That is ion trap analyzer. That is the ion trap mass analyzer. And Fourier ion FTICRMS, in this case, the ions which are formed, they are subjected into high electric and magnetic fields. Depending on that, further ionization takes place, and these are under very high, that is 2 Tesla or 4 Tesla magnetic field is applied, and then these ions, they keep on moving in the under the influence of magnetic field, so they can be detected. So LCMS, it can be applied to the separation of various biological samples, like first, though, it is applied for the identification of bile acid metabolites. So we analyze the mass, the mass spectra at different peaks which are coming, like these are the different peaks at 10.24, or this is a minor metabolite, and different peaks which are found in the bile sample, and you can then, depending on fragmentation pattern, you can extract the mass, and depending on mass by charge ratio, you can assign the molecular structure or the fragment which may be formed. Like in this case, we have extracted the peak in this minor peak at 9.41, and you get different fragmentation pattern which is corresponding to the structure of cholic acid. So depending on the mass spectra, at 407, that is corresponding to a fragment of mass M by Z 407, this is the fragmentation pattern, and based on this fragmentation pattern, we can say that this sample contains cholic acid. So various drugs and various proteins or various, they can be analyzed, and like in food, various toxins like aflatoxin, B1, B2, G1, G2, they can be analyzed, and their presence can be confirmed in the samples. So I can say that LCMS is very suitable, and it is extremely sensitive and very specific technique for the analysis of pharmaceuticals, and it plays a very important role in the study of drug metabolism analysis, identification and characterization of the impurities and degradation of samples, they can be easily studied. So only this much, that is, we will discuss. That is the mass spectrometry, how it is utilized for the analysis of various products. And if you want more, I can discuss some mass spectra. You can see how carbon dioxide, it can be detected samples. Carbon dioxide का molecular, it has oxygen, and from carbon dioxide you can have a carbonyl fragment. Oxygen, that is cation, it has a mass of 16, and carbonyl, it has a mass of 28. So, and carbon dioxide, if you ionize it, it gives a molecular ion peak at 44. So 16, at you have a peak at 16, 28 and 44. If these three peaks are present in your sample, this indicates that you have a carbon dioxide molecule in the sample. You have carbon dioxide. दूसरा देखो आप प्रोपेन का, प्रोपेन dissociates to form methyl radical, and propane has a mass of 44. On ionization it forms molecular radical ion, and M by Z 43 and M by Z 28 and 29. Basically 29 molecular ion is formed in excess. This is the molecular ion, this is the main fragment which is formed, and in this 44 is the molecular ion peak. If you have cyclopropane, M by Z is 42. Now you can differentiate between propane and cyclopropane. Between the two molecules you can differentiate. So time is very short. In between the two, carbon dioxide, propane and cyclopropane, you can have the fragmentation pattern, and the different fragments, like at peak at M by Z 39, 28, 41 and 42. 28, 39, 41, 42. This indicates that this sample is cyclopropane. बस बेटा इतना ही करेंगे, ठीक है, बाकी फिर देखेंगे कभी. So thank